Okay, welcome to another math special video, and in this math special video we are going to prove the ladder theorem for areas, and the original work is by Stengel. Okay, Stengel. This result was first given by Stengel, but you can search Google or wherever you want, you won't find a proof of this theorem. Okay, the result, you can find many videos on YouTube which makes use of this particular relation, this particular formula to solve problems, but it won't give you a proof. So that's why I made this video about the proof of ladder theorem. Okay, this theorem states that if we have any triangle PQR and consider any two CVNs, this can be any one CVN, this can be any one CVN, QN and RM. Okay, any two CVNs. And let's denote the area of triangle MOQ by X, QOR by Y, and RON by Z. Then this relation holds 1 over delta plus 1 over Y is equal to 1 all over X plus Y plus 1 all over Y plus Z. Okay, where delta is the area of triangle PQR, the given triangle. Okay. Now, I've considered three cases here. Okay. The first case is that both the angles at Q and R are acute. The angle P can be right angled, be a right angle or an obtuse angle. It doesn't matter. Q and R. Okay, both the angles at Q and at R are acute angle. The second one is that one of the angles at either Q or at either R is of 90 degrees, is a right angle. I've taken the 90-degree angle to be at Q. Okay, similarly an obtuse angle at Q, you can take it at R as well. I've taken it at Q. Okay, all right, now let's begin with the proof. But before beginning with the proof, let's consider an important result that we're going to use in the proof. Okay, all right. I could make this side shorter, doesn't matter. This is a straight line. It doesn't look like a straight line, but it is a straight line. Okay, this is parallel to this, and this too. Let's call this A, let's call this B, let's call this C. Now let's look at triangle X, Y, Z. Okay, let's look at triangle XYZ. Then this angle is equal to this angle, and this is the common angle. So these two triangles, this triangle, let's call this O. Okay, let's call this O, and let's call this D. So this triangle, let's call this M. XOM and XYZ. These two triangles are similar. So what do we get? Let's call this side X. Okay. Let's call XM as X and XZ as Y. Then, since these two triangles are similar, what we get is A over B is equal to A over B is equal to X over X plus Y. Okay, X plus Y. So let's call this equation 1. And similarly, this is a common angle to both of these triangles, and this angle beta due to parallelism. Okay, corresponding angles. And since these two lines are parallel, what we get is that this, if this angle is beta, then this angle is also beta. Now, using similar proportionality relation between the similar triangles, what we get is A over C is equal to beta means Y all over x plus y. Now, if we add 1 and 2, what we get is a by b plus a by c is equal to x by x plus y by x plus y. This means x plus y over x plus y, which is equal to 1. Okay. Now, if we take this a as common, then we get it as 1 by b plus 1 by c is equal to 1 by a. Alright. Now, if b, c and a are integers, this is also called an optic equation. It's an equation which arises in number theory. Okay. But we are not concerned with that, and it is not necessary that a, b and c are always integers. Okay, integers or positive integers. I'm a little bit confused. All right, let's forget that. We get this relation. So 1 over this is equal to 1 over this plus 1 over this. That's what we need. All right, and this holds even if these are perpendiculars. Okay, in this case also, it works in this case also. If we have something like this, it works in this case as well. It works in this case as well, because since these lines are perpendicular to the same straight line, these lines must be parallel. So proceeding similarly, we get the same result. All right. Now let's try and use this result. Let's first consider this triangle. This is the most easiest case. Okay. From R, construct a line. Construct a line parallel to PQ. Okay, parallel to PQ. So basically, this is also 90 degrees. Now produce QN. To meet the line, we just construct it. Let's call this point, okay, let's call this point, what do we call this point? MNOPQR. Let's call this S. Okay, let's call this point S. Now, let's say this length, MQ is A, MQ is A, PQ is C, and RS is B. Okay, RS is B. So now let's drop two perpendiculars, one from O like this, one from N like this. The area of this, let's call it H1, let's call it H2. Okay, H1 and H2. Now let's see, for H1 we have this condition. This is 90 degrees, this is A, this is again 90 degrees, this is B, and what we have is H1. Okay, what we have is H1. So using the relation we just discussed, what we get is 1 over H1 is equal to 1 over A plus 1 over B. Okay, this is what we get. Next, consider H2. H2. What we get is this is B, this is C, and this is H2. Okay, H2. This is H2, this is C, and this is B. This is it. So using this relation, using the same relation, what we get, 1 by H2 is equal to 1 over C plus 1 by B. Now let's see, 1 by H1 minus 1 by A is equal to 1 by B, and from here what we get is 1 by H2 is equal to minus 1 by c is equal to 1 by b. So equating these two, this and this, the left hand sides of both the equations, what we get is 1 by h1 minus 1 by a is equal to 1 by h2 minus 1 by c. Okay, rearranging the terms, 1 by h1 plus 1 by h2, 1 by h1 plus 1 by c is equal to 1 by a plus 1 by h2. This is what we get. Okay, this is what we get. Now, let's focus on this equation. Let's multiply the denominators by half. What we get? 1, 1, 1, 1. Half, 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 half. And h1, c, a, h2. Now let's multiply the denominator further by QR. QR, 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 QR. That is half h1 QR. Half h1 QR means this triangle QOR, whose area is, the area of triangle QOR is y, plus half c into QR. Half c into QR. C into QR means area of triangle PQR, which was delta. Okay, 1 by delta is equal to half a into QR. A into QR means this triangle. Half a into QR means this triangle, means x plus y. Okay, 1 by x plus y, plus half h2 into QR. Half h2 into QR. h2 into QR means this triangle, which is y plus z. Okay, y plus z. So the ladder theorem holds in this case. So 1 by delta plus 1 by y is equal to 1 by x plus y plus 1 by y plus z. It holds in this case. Now let's consider the remaining two cases. Okay, the remaining two cases. Let's draw perpendiculars as before. Just remember, okay, this is x, this is y, this is z. Now let's drop a perpendicular like this. Let's drop another perpendicular like this. Another perpendicular like this, and another perpendicular like this. Okay, this is O. This is x, this is y, this is z. Now let's call this as h1, this as h2, this as h3, and this as h4. Okay, this is x, this whole triangle, it has area y, and this has area z. Okay, here it is. Now, you won't find a figure so easily or so readily over here. Okay, so we need two more lines. A line parallel to the altitudes at Q and R. Okay, this is parallel to the altitudes. This is parallel to the altitudes. Okay. Okay. This is also parallel to the altitudes. These altitudes reconstructed. And so this is also 90 degrees. Now produce the cVians to meet these two lines. Okay, produce this cVian like this, produce this cVian like this. like this. Okay, all right. Now let's say this length is A and this length is B. Next, produce this line and this line like this and like this. It doesn't look like a straight line, okay? Okay. I don't need that. At least right now. Let's call this whole length as C and this whole length as D. So what do we get? For H1, we have something like this. H1, we get something like this. See? This is C, this is D, and this is H1, okay? So this is C, this is D, this is H1. So 1 over H1 is equal to 1 over C plus 1 over D. Now let's consider H2. Then for H2 we have A, B and H2. This triangle, this triangle. So 1 by H2 is equal to 1 by A plus 1 by B. Similarly, for H3 we have A, okay? H3 we have, for H3 we have A and then D. So 1 by H3 is equal to 1 by A plus 1 by A and D, okay? A and D. And similarly for H4, what we have is, here's B and here's C. See? For H4. So this is 1 by B plus 1 by C. Now 1 by H1 plus 1 by H2. Okay. 1 by H1 plus 1 by H2 is equal to 1 by A plus 1 by B plus 1 by C plus 1 by D. 1 by A plus 1 by B plus 1 by C plus 1 by D. Okay? Alright. So similarly, 1 by H3 plus 1 by H4 is equal to 1 by A plus 1 by B plus 1 by C plus 1 by D. Right? D. Okay. So what we get is 1 by H1 plus 1 by H2 is equal to 1 by H3 plus 1 by H4. Now, just like in the previous equation, let's multiply the numerators by half and then by QR. Okay. So what we get is one, half, 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 half. H1, H2, H3, H4. H1, H2, H3, and then H4. Okay. Okay. Now, let's multiply. This was P, this was Q, this was R, this was M, this was N. Okay. Okay. Let's see. Let's multiply each of them by QR as well. Each of the denominators. QR, 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 and then QR. Now, half H1 into QR means this entire triangle. So 1 by delta, this means 1 by delta plus half H2 QR. H2 QR means this triangle QOR, whose area is 1. 1 by Y is equal to H3 means MQR. H3 times QR means MQR, triangle MQR. So this is, its area is X plus Y. This entire triangle means the sum of this triangle plus this triangle in terms of area. So the area is X plus Y. 1 by h4 qr. h4 means this, qr means this. So this is the triangle, okay, whose area we've obtained here, and that area is y plus z. Y plus z. Wow. So for this triangle also, the result holds good. Okay. Result holds. Okay. Now let's consider the final case. Let's consider this final case. And if we are done with this final case, we're done with the proof of the ladder theorem. Okay? Now consider any angle greater than angle at Q, this angle at Q, and less than this angle PR, let's say this is S, PRS, okay? Greater than this angle, but less than this angle, this angle. Less than this angle, greater than angle at Q, this entire angle. So, maybe this is that angle, okay? This might be one angle. And so this triangle is possible. Now draw lines parallel to this line. It's up to you which angle you want to choose, okay? It must be greater than this angle and less than this angle, okay, this shaded angle. So once you've chosen that angle, you can construct that angle like this, passing through M, okay? Angle M, let's say this is K, MKS is that angle which you have chosen, okay? Now after you've fixed MK, what you do is you draw lines parallel to MK through P, O and N, okay, P, O and N. So maybe this is the line, this is the parallel line, this is the parallel line, and this is the parallel line. Next, what you do is that you draw lines parallel to these lines which pass through Q and R as well. So since this is greater than this angle, it will be something like this. It will be something like this. Okay, it will be something like this. And also at R, since it is less than this angle, it will be maybe something like this. Okay. Rest of the things, it's the same, okay? Produce this Sevian RM to meet this line, and this Sevian QN to meet this line as shown. Let's say this length is A and this length is B, okay? And let's say let's produce these two sides as well. This meets this line somewhere over here, and this one somewhere over here. This entire line, this entire length, we denote it by C. This entire length, we denote it by D. Okay, just like in the previous case. So if we say this is H1, this is H2, this is H3, and this is H4, the lengths of these lines, okay, as H1, H2, H3, and H4, then we do not have the perpendiculars as in the previous case, but we can still use the theorem or the relation we first discussed before beginning with the proof in this case as well. Let's see. Since these are parallel lines, okay? Let's see. For H1, we have H1 means this triangle and this triangle. So 1 by H1 is 1 by C plus 1 by D, C and D, okay? For H2, let's see this triangle, okay? This triangle and this triangle. So for H2, it is 1 by H2 is equal to 1 by A plus 1 by B. Next, for H3, we have this one, this triangle, this is X, this is Y, this is Z, okay? The areas. For H3, what we have is A, and then H3 means A and D. So A and D, not A and B. A and B, it cannot be A and B. Okay. And finally for H4, what we have is this triangle C and this triangle means B. Okay, so 1 by H4 is equal to 1 by B plus 1 by C. Now if you add just like in the previous case, what do you get is 1 by H1 plus 1 by H2 is equal to 1 by H3 plus 1 by H4. And we can also multiply it as in the previous case. What we get after multiplication, we multiply each of them by half and QR. So this is the relation we're going to get yet again, okay? But this does not follow as readily as in the previous case, okay? We got this relation. We multiply each of the denominators by half and QR, so we get this relation. So this is not enough. Why is that? Because these are not altitudes, not the altitudes, okay? These are not the altitudes. So let's say this angle is theta, okay? This angle, what do you call this? Angle MKQ, this angle is theta. Then so is this angle. This angle is also theta. This angle is also theta. And this angle is also theta. Okay? Now, if you drop a perpendicular like this, okay, what we have is, okay, this is H3, this is theta, and we've dropped a perpendicular like this. So the length of this perpendicular is H3 sine theta, isn't it? H3 sine theta, because sine theta is equal to this length by H3, so this length is H3 sine theta. Similarly, if we drop a perpendicular like this, now this is H2, this perpendicular, okay? Here we have another perpendicular. Here we have another perpendicular. Okay? Then, if this is H1, we will get this, the length of the perpendicular, as H1 sine theta. Similarly, if this is H3, it's H3 sine theta. If it's H2, it's H2 sine theta. And if it's H4, it's H4 sine theta. So let's multiply the denominator by sine theta as well, times sine theta. I'm multiplying the denominator, eh? Sine theta, sine theta, sine theta. Okay? Alright. Now let's see. H1 sine theta means this altitude times QR. H1 sine theta by QR into QR. H1 sine theta into QR means base into height, and we also have half over here. So this is the area of triangle PQR. Okay, so we have 1 by delta plus H2 sine theta. This is H2 sine theta. This is H2 sine theta. Okay, H2 sine theta, and H2 sine theta times QR means this triangle QOR, whose area is Y. QOR, whose area is Y. Now H3 sine theta means this altitude times this length means area of triangle MQR. Okay, height into base into half. H3 sine theta into QR into half means this triangle whose area is x plus y. And finally, H4 sine theta. This is H4 sine theta. H4 sine theta. This is H4 sine theta times QR times half means this triangle Q and R. And Q and R means the triangle with area y plus z. So basically, in this triangle also, 1 by delta plus 1 by y is equal to 1 by x plus y plus 1 by y plus z holds. Okay, this holds. Hence, we've proven the ladder theorem completely. We've considered each and every possible case. Okay, each and every possible case. And in each and every possible case, we obtain the same relation. I've already explained to you about the symbols. Okay, so the ladder theorem actually holds. And you won't find a proof of the ladder theorem anywhere if you search on Google or on YouTube. But on YouTube, you're going to find a number of videos which uses the ladder theorem as a tool to solve for some areas. Okay, all right, that's for today, and I'll give the links to the scholarly articles or websites which I've consulted to give this proof. Okay, all right, thanks for watching.